Okay, we were trying to solve this question. We came up, or the horizontal forces all add up to 0. The horizontal forces that can be identified are this f of x pushing to the right to counteract this horizontal part of this tension pulling to the left. So that that results in a very easy equation. The horizontal component of this tension equals the horizontal component of this force at the pivot point. This is nice to look forward to using in the future because it's so simple, but both of those are unknowns to us right now and are basically useless. But we didn't know that to start. I'm going to call that equation number 1. The next equation we can consider is the net force in the y direction. Net force in the y direction is equal to 0 because nothing is accelerating up and down. In the y direction, we have a big tension downwards that we know it's equal to this weight. I'll just put it there, tension down. There's this wire. This wire lifts up. And it's upward, so there's a plus tension y. Don't confuse these two. I'm going to make this a block T, just to remove all confusion. I'll just change my font, basically, for this tension downwards. There's tension upwards caused by the wire. There's weight downwards, just the weight of the beam itself. And this Fy, I'm not sure, actually I'm going to put it up just because it's slightly less confusing. Because if this ends up being negative, then I know it was actually downwards. But that allows me to put a plus Fy here so that if I ever solve this equation and it ends up negative, I know that this was actually turned the other way. So I would say unknown forces aim in the positive direction when in doubt. This together, there's a whole bunch of unknowns here, but together I can put the negatives on one side and say that this tension plus the weight must in some way be balanced out by the wire pulling up and the force of the pivot pushing up. Again, I don't know. This is unknown to me. This is unknown to me. These two are not. So this equation has some promise that I can use it fairly quickly. Let's look at the torques. Net torque is equal to 0. And if my pivot point is here, then all the perpendicular forces at some length have a torque. So there's a torque caused by this weight here, and that's in the clockwise. This is in the negative direction. So the clockwise or the negative rotation, and that's caused by the weight itself at half the length? Whatever the length of this beam is, it's at half that length. And that's helped out in the in the clockwise direction by this tension, which has an effect at the full length of the lever arm, which is the entire beam. And both of those, the only thing keeping this beam from twisting in the clockwise direction and crashing down is this wire, and only the perpendicular part of this tension. So this, and that's in the counterclockwise or positive direction, so that's Ty. So putting all the negatives to one side, I have the weight L. Oh yeah, and that is at the working at the full length of the lever arm. Again, well, I'll point it out here. The length ends up being a common factor, so it crosses out. The only thing length is, I brought the negatives over, just leaving this positive value here on the left. Length is everywhere. It's on all of these terms. It's called a common factor. Boom, boom, boom. I can divide by L both sides. Now L is gone, and I have just a relationship amongst forces. There's the weight. That's half the weight. That's that factor of a half is still there. Plus this is equal to. All right, and I think that's pretty good. I think I can now come up with this, because this tension is equal to that weight. This weight is given, and half of that weight and all of this tension are being balanced, are equal to this, just this y component. So we can figure out now Ty from this. So this is going to be this is my third equation. 3 equations are generated, and this equation is enough now for me to solve for this component Ty. So now at least I know the perpendicular component of this tension, and I think I was given all of these sides. So I can use a geometric principle of common of proportional triangles, and then I can easily come up with to calculate this tension upwards in the cable. I shouldn't have called it TU. That's a pretty bad name for it. I'll call it T now that I've given this one a different name. So you can use geometry, but another way is we know this side, we know that side, we know that side, so we could use these two sides and come up with this angle if we wanted. We could say tan of theta. Now what am I trying to do? I'm trying to connect this vertical component to this entire t component. And I could say tan theta is equal to opposite over adjacent. And the opposite side is here. The adjacent side is this entire length. So this entire beam length by this, whatever that is, and that's also equal to opposite is Ty over Tx. So that's also equal to Ty over Tx. So I can create an equivalence between ratios of tensions to ratios of distance here. I can just, this has to be true for both of those. And so now I can solve for Tx. I have Ty. I have these sides. I can solve for Tx. So now I know Tx and Ty, so I can solve for T using Pythagoras. A squared plus b squared is equal to c squared, or some students could solve directly using other geometric relations. But the point is, now I think we, once we know just Ty, and because of geometry, we can solve for Tx and T. So now we know T, Tx, and Ty. So let's make that assumption. That's part that helps us with part A. So this was part A solved. Part B is find the horizontal component of the force. Right here, I need to know Fx. Fx is equal to Tx, and if I'm saying that we've solved for Tx2, we've also just solved for part B. Comes directly from there. And part C, Find the vertical component of the force exerted on this wall. Alright, this vertical component, Fy, if I know Ty, I can substitute that in there. I know the weight, I know this tension here. I know everything, and F of y can be solved for. I don't know if that's positive or negative. If it ends up being positive, then this diagram is accurate. If it does end up being negative, and I don't know that it isn't, it would be pointed downward. Alright, so you can see once you set up your diagram, you identify all the forces, you state each one of these equations, and you make some careful algebra and do some careful geometry, everything can fall in place.